Hello everyone. Today we will solve 2 or 3 questions related with the VT graph. Then we will start equation of motion derived by the or proved by the graphical method. So this is your first question, and as for this question, this is a VT graph and you will be calculate distance and displacement by using this VT graph. So let's start. First, we calculate distance, then we calculate displacement. So as for this question, this is a slope, and we know that this area represents distance as well as displacement, and this is also a slope in negative direction. So this area is also represent distance or displacement of the graph, because we have already taught in previous class that the area of the VT graph represent displacement or distance. That means you already teach that slope of VT graph, that means slope means tan theta, which is equal to dv upon dt. That means v2 minus v1 by t2 minus t1, which produce acceleration. So slope of VT graph produce acceleration, and area of VT graph produce displacement or distance. So तुमको बारंबार हम कहचे जे VT ग्राफ प्लस स्लोप मींस डिवीजन के बुझेबा dv upon dt tan थीटा के बुझेबा. So slope VT ग्राफ रो स्लोप मींस v और t डिवाइडेड है, तो tan थीटा इज इक्वल टू dv upon dt. So slope of VT graph produce acceleration and area of VT graph produce distance or displacement. So in this case we want to calculate distance and displacement. So we take the area under the VT graph. So in this case, how much area covered by this VT graph? Let's start. This is look like a right triangle. So in right triangle, suppose if we represent a line to the right triangle, suppose OAC, then triangle OAC area of OAC or area of triangle OAC, which is represent distance S1. Suppose this is first distance S1, then third comes second distance comma. So this distance will be equal to, this is the right triangle, so formula area of the triangle is half into base into perpendicular. So base here 0 to 5, that means base is 5 into perpendicular AC is the perpendicular which is parallel to the 0 to 10, that means 10. From origin the velocity is 10, which is parallel to the AC. So AC is equal to 10. So area is equal to 25, which is represented as distance. So distance, so we use the unit meter, but area unit meter square, no doubt. किंतु जब वो area represent करूँ distance के, so हमें distance हिसाब से unit के लिखना meter. Next, distance हमें पाई वाला, ये यार distance देखो. This is also a triangle, right triangle. If we represent a name of this triangle CEQ, then triangle CPQ, and area of this triangle CPQ, area of triangle CPQ also represent the distance of this VT graph in negative direction. So in this case also this area represent distance, so we can write distance S2 because this distance is written as S1, so this distance is written as S2. So S2 is equal to because the distance is represented by the area of the VT graph, so S2 is equal to area of this triangle PCQ. So area of this triangle is half into base is equal to CQ is the base, and instead of CQ we can be written that this is 5 CQ is represent the limit between 5 to 10. That means 10 minus 5 is equal to CQ. Clearly बुझल because 5 रु तमे 5 जाए गले ही 10 हवा, so 5 जाए गले ही 10 हवा, तो CQ केते दूर जाउछ 5, तो ई हिसाब रे कैलकुलेट करबो. If you subtract 10 to 5 then CQ is found. Origin to this is 10, origin to this is 5, so this is equal to 10 minus 5 is equal to CQ. हला तो भी मन रखबो जे तुम 5 रु 10 जाउछ ले 5 जाई गले ही 10 तक जीव, तो CQ केते जाई जाइछ 5, so CQ is equal to 5 and perpendicular CP is parallel to the O10, so origin to this velocity in negative direction is 10, so this is equal to 10 which is parallel to the CP, so we can be used CP is equal to 10. So half into भूमि base जगह तुम यूज करो 5 and perpendicular जगह तुम यूज करो 10. In this case also distance is 25 meter. तो मीटर कैसे लगवा, एरिया बार करूँ तो मीटर स्क्वायर लगवा होता है because the area of the VT graph represent distance. So जहाँ भी आंसर बाहरी बा एरिया ऑफ जे तो डिस्टेंस के रिप्रेजेंट करूँ मीटर लगवा. Then total distance will be dash. Initial distance 25 from this, and in this case also final distance 25. So total distance covered by the body is, suppose S is equal to S1 plus S2 is equal to 25 plus 25 is equal to 50 meter. The edge distance is a scalar quantity, so we can use only the magnitude of the two distance. Clearly बुझलो ना का प्लस डायरेक्शन रहे छे या माइनस डायरेक्शन रहे छे. So in a plus direction में 25 पछे, माइनस डायरेक्शन में 25 पछे, तो प्लस माइनस कैंसिल करी टोटल डिस्टेंस 0 हेबा कथा because distance is a scalar quantity. So से नेगेटिव डायरेक्शन में भी 25 जाओ कि नेगेटिव डायरेक्शन में 25 जाओ कि पॉजिटिव डायरेक्शन में 25 जाओ, से डिस्टेंस कवर करूची जेहेतु स्केलर क्वांटिटी से बका जामे डिस्टेंस के सबले ऐड करना मैं 50 हेला. And then we calculate displacement. So in this case in positive direction distance or displacement suppose S1 is 25, in negative direction distance or displacement is 25, but displacement is a vector quantity, so in negative direction this distance is represented with the negative sign because displacement is a vector quantity, and in negative direction this distance is represented with negative sign. The net distance will be 0. Net displacement will be 0. Net distance 25 है, तो मैं आगे जाऊँ 25 पछ के जाऊँ 25, तो net distance तुम्हें कवर करो 50 मीटर, किंतु displacement तुम्हें गुटे पॉइंट रो 25 जेते आगे जाइछो सेते 25 रिटर्न करो, तो displacement जेहेतु वेक्टर क्वांटिटी गुटे माइनस साइन आसला गुटे displacement नेगेटिव डायरेक्शन रो -25 आला, तो total displacement will be 0. So this is your first question. Then plus 2 minus 2 5 10 15 and this is velocity time graph v along y-axis and t along x-axis. So in this velocity time graph we produce displacement time graph. So तुमको क्वेश्चन रे दीचे velocity time graph किंतु तमे बाहर करबो displacement time graph. That means how can you derive displacement time graph from the velocity time graph? So देखो हमें सपोज ग्राफ बनेलु displacement and time. तो displacement time graph रो हमें बनेबा আছে. So तमे जानछो जे area of the velocity time graph produce displacement. So during this time 0 to 5 how much area covered by this velocity time graph under the time axis? This area, and this area represents the initial displacement, and this area will be breadth 5, length 2 because 0 to 2 is 2 and breadth 0 to 5. So 5 into 2 10. That means initial displacement is 10 and that displacement is covered by the body with respect to time 5 seconds. So in 5 seconds the displacement covered by the body is 10. How can you obtain this displacement? Displacement is the area under the VT graph. Then in this time 5 the area covered by this VT graph is and this area is equal to 5 into 2 length into breadth into length 5 into 2 that's 10. So in 5 seconds the distance covered by this VT graph is 10 meter. So in 5 seconds displacement time graph with respect to 5 seconds distance is 10. Then up to 5 to 10 seconds, what is the velocity of this VT graph? Up to 5 to 10 seconds, the velocity is 0. Velocity is 0. देखो 5 to 10 भितरे velocity y axis रे अच्छे देखो तो 5 to 10 भितरे velocity देखो y axis रे कितना अच्छे 0. So velocity will be 0. So when velocity will be 0? When the distance is constant, displacement is constant. Because displacement constant रहले ही हमार velocity 0 है. तो देखो 5 to 10 भितरे तमर displacement of graph इटा पड़ी आसला 5 to 10 भितरे. अब देखो सॉरी 5 सेकंड रे तमर distance बा displacement 10 हला. So 5 और 10 भितरे तम ई ग्राफ बने देला. Then एबे टाइम देखो 5 to 10 सेकंड रे काना हवा देखो तब लास्ट के टाइम 15 सेकंड रे काना हवा देखो. So between 5 to 10 seconds the velocity is 0 because y axis रे देखो velocity 0 अछि between 5 to 10 seconds. So 5 to 10 seconds भितरे displacement का straight line है. 5 to 10 seconds भितरे displacement का straight line है because suppose that this is s2 10 seconds रे अछि and this is s1 covered by the body in 5 seconds. So s2 minus s1 is equal to 0 होगा. So velocity is 0. So between 5 to 10 seconds velocity is 0. So when velocity is 0, we know that in case of displacement time graph, when velocity is 0, the graph is parallel to the time axis, then velocity will be 0. So in this case, velocity will be 0 from 5 to 10 seconds. So in this case, 5 to 10 seconds, the displacement graph is parallel to the time axis, then velocity will be 0. Clearly बुझलो. देखो भल कर देखो VT ग्राफ रो तमे डिस्प्लेसमेंट टाइम ग्राफ बनोछ हला इनिशियली तो एक भीतर तम डिस्टेंस केते कवर हिचे तार एरिया रो पाइ गलो डिस्प्लेसमेंट. देन 5 टू 10 सेकंड भीतर तमर वेलोसिटी केते रहउछ 0. तो 0 केतेबेले रहबा 5 to 10 सेकंड भितर से डिस्प्लेसमेंट टाइम ग्राफटा पैरेलल टू द टाइम एक्सिस प्रूफ करबे देखो s2 - s1 0 हो तो t2 - t1 जा दियो हला तो 5 to 10 सेकंड भितर 0 तबे between 10 to 15 सेकंड how much area covered by this body how much area covered by this body this breadth is 5 because 10 to 5 15 जाय छै तो 5 and length is -2 so final distance is 5 minus 2 5 into -2 because this is parallel to this axis and this is -2 so this is also -2 so 5 into -2 give the area of this VT graph. So in this case distance s2 is equal to area of this graph. So area is equal to 5 into -2. This is -10. तो distance टा -10 ही जाउची तळके पळे आवश्य मन रहिथियो तळके पळे आवश्य आ सेते बेले तमर वेलोसिटी केते रहउचे वेलोसिटी रहउचे तमर -2 रहउचे सो देखो ए तमर तळके 10 to 15 रे तमर डिस्टेंस टा तळके पळे आसबा -10 तळके पळे आसबा मींस ऊपर के से 0 ରୁ 10 प्लस 10 ऊपर के जाई छे से एबे 10 ରୁ 0 को पळे आसबा प्लस से -10 रिटर्न कर देला जदि से हिसाब रे भी तुम बुझी नहीं पारबा बेले वेलोसिटी देखो -2 हेबा कि नहीं 10 to 15 भितरे ई 10 to 15 भितरे वेलोसिटी -2 हेबा कि नहीं जदि होचे बेले डिस्प्लेसमेंट टाइम ग्राफ राइट हेबा देखो 10 to 15 भितरे this is initial position हेबा 10 in 10 second the body cover initial distance is 1 and in 15 second the body cover final distance is 2 so velocity will be s2 minus s1 upon t2 minus t1 so s2 is equal to 0 0 minus s1 is equal to 10 and t1 first time the body cover s1 distance so t1 equal to 10 and final time t2 is equal to 15 because I am calculate करू to 10 to 15 भितरे 10 to 15 भितरे तम velocity so 15 minus 10 is equal to 5 that means -2 तो हो कि नहीं so velocity in -2 हो this means this slope will be right क्लियरली बुझला जैसे 0 ରୁ 10 सेकंड ऊपर के गला तो इन रखा जाय छै ई सेकंड केस में तम -10 डिस्टेंस कवर करू छै तो तम रिवर्स कर देबो बोले से डिस्टेंस ता -10 के रिप्रेजेंट करबो बिकॉज़ ऊपर के जाय छै +10 डिस्टेंस रिवर्स ओके बुझल छै आ रिवर्स कर देबो में -10 डिस्टेंस ही जो पूरा सीधा लाइन का जे नहीं करी बिकॉज़ तमर टाइम 10 to 15 भितरे तमर -10 हो छै तो 10 सेकंड तो तमर रिवर्स करो 15 जा -10 क्लियरली बुझो बिकॉज़ 10 to 15 भितरे तमर एरिया कवर बाय द बॉडी इज 5 into -2 तो 10 to 15 भितरे तमर -10 होचे तो 10 to 15 भितरे तमे डिस्टेंस के रिवर्स कर हला एबे देखमा हमें देखो बही रे तो एक्सेलरेशन टाइम ग्राफ ही नहीं दबा किंतु बुझी ली कि एक्सेलरेशन टाइम ग्राफ का रिप्रेजेंट करछि सो हाउ कैन वी ड्रॉ डिस्प्लेसमेंट टाइम ग्राफ बाय वेलोसिटी टाइम ग्राफ प्लीज focus this graph and if you have any doubt then you please watch this video again and repeat एक्सेलरेशन टाइम ग्राफ किछि तो तम एक्सेलरेशन टाइम ग्राफ देखो this is time x axis this is acceleration y axis so if we draw a slope in this graph suppose straight line graph uniform acceleration sorry uniform acceleration है acceleration का magnitude समान रहा this time हो छाड़ो हम तो इना खाली बुझबा अच्छे तो देखा हमें ये टाइप का भी ग्राफ नंबर किसी असुविधा नहीं तो जब हमें स्लोप का आमा तो तुम्हें जाएंगे तो स्लोप इज ऑलवेज इक्वल टू dy by dx because y axis perpendicular के बुझेबा x axis बेस के बुझेबा perpendicular base is tan theta So in this case, acceleration is equal to tan theta is equal to dA upon dt. That means tan theta is equal to a2 minus a1 by t2 minus t1, which is equal to jog. खाली मना रखियो आ गुरे जिनिसटा तुम एक्सेलरेशन टाइम ग्राफ रो बाहरी बा जदि हम एरिया बाहर करबा. If you want to calculate the area of this AT graph, area under the AT graph, एटा मना रखियो एरिया एटा बहुत इंपोर्टेंट परीक्षा का दे under the acceleration time graph is represent velocity. Suppose this is something acceleration 0 to 2 acceleration. Suppose, and this 2 acceleration each happen or take place in time 4 seconds. So if we draw a graph, then this slope is produced OAC. So this acceleration, this triangle is represent OAC, area of the triangle OAC is equal to half into perpendicular is acceleration into time. Clearly बुझलो. तो acceleration in time is equal to acceleration and time. Acceleration, this is average acceleration भी कहि पारबो तमे. Average by 2 अच्छे तो average acceleration कहि पारबो. Initial acceleration केते अच्छे 0, final acceleration 2 अच्छे. So a minus 0 is a. we direct a लिख दीजिए. So average acceleration into time is equal to, we know that velocity is equal to acceleration upon time. Acceleration is equal to velocity upon time. So velocity is equal to acceleration into time. Acceleration into time. So in this case we can use half into acceleration. Acceleration is 2. Into time is 4. That means 2 to cancel 4. And this 4 represent velocity, 4 meter per second. Because if just calling acceleration is equal to velocity by time, the velocity is equal to acceleration into time. So in this case, instead of acceleration into time, we can be use velocity. So this is velocity. Average velocity by 2. So मन रखिथिबो area under the acceleration time graph is produced velocity. मन रखिथिबो ठीक. So this is a question x and y axis. This is acceleration time graph, and in this case find velocity. So you know that area under the just calling AT graph is represent velocity. So that what is the area of this graph? Half into base is 11 into perpendicular is 10. This is 50 and this area is equal to velocity. So मन रखिथिबो area under the acceleration time graph is produce velocity. मन रखिथिबो multiplication of area means multiplication of. तो सेटा तम acceleration of velocity multiply करना दबो velocity. Acceleration of time multiply करना दबो velocity. Next हम पढ़मा equation of motion. सो इक्वेशन ऑफ मोशन नेक्स्ट क्लास रे स्टार्ट करबा थाउ एतकी नेक्स्ट क्लास में पढ़बा आ के क्वेश्चन करना ना देखि दियो टाइम ही नहीं हवा टिके देखि दियो इक्वेशन ऑफ मोशन by graphical method. So हमें 4 इक्वेशन पढ़िथिलु v is equal to u plus et which is first equation of motion, then s is equal to ut plus half at square, then v square minus u square is equal to 2s, then u is equal to s and px is equal to u plus a by 2n minus 1. Then all of these equations we can be derived by using calculus method, derivative integration. But in this case all of these equations is derived by the graphical method. Graphically हमें derive करो. So देखो हम फर्स्ट ग्राफिकल मेथड ओटा जे डायग्राम मोडे बनेमा सपोज अभी डेरिवेशन ला तो vt ग्राफ रो बाबा वेलोसिटी टाइम ग्राफ रो ही डेरिवेशन है मन रखथिबो all of these equation can be derived by the velocity time graph. So this is velocity and this is time. Suppose initial time the body having some initial velocity u and equal to uniform velocity uniform acceleration derive hoba jodi with respect to time the velocity of the body is equally increases. So if we plot a graph or graph, then this graph is straight line. After some time t second the body cover or reach final velocity v and in this graph it is a velocity time graph. So if we want to represent a slope of velocity time graph, then their slope is give acceleration. Suppose at this point we want to represent the theta slope. The t time रे होचे then देखो भल कर देखो 0 सेकंड रे तम बॉडी रो किछि इनिशियल वेलोसिटी थिला u, then with respect to equal interval of time the velocity of the body is increases up to final velocity v in time t. So in time t the final velocity is v. So in this case also we plot a graph. Suppose this graph is a b, straight line graph is ab. ना दीदा में c d है एतके लिखि दबो अबे जहां जहां আছে তুমি লিখি দবো আগে নো যে let initial velocity of body is u and final velocity is v. u होचे तमर इनिशियल वेलोसिटी और v होचे तमर फाइनल वेलोसिटी. Then t is the time taken by the body moves with final velocity or reach at final velocity. मोस्ट विथ लेवल में चलो रीच एट लेवल चलो अब देखो. सो एबे हमें फर्स्ट बार करबो फर्स्ट इक्वेशन ता तुम बाहर करबो वेलोसिटी टाइम ग्राफ रो स्लोप एंड so first equation is v is equal to u plus at. So how can this equation is derived by using graphical method? देखो, so first this velocity time graph or slope is represent acceleration. So slope of this VT graph represent acceleration. So slope देखो A B C रू बाहर करना triangle A B C slope tan theta which is represent acceleration, that means tan theta is equal to acceleration, and acceleration will be equal to perpendicular by base. So in this case perpendicular is BC, this triangle ABC triangle perpendicular is BC and base is AC, perpendicular by base is equal to tan theta, and tan theta slope is equal to acceleration because velocity time graph dv upon dt perpendicular ने dv बुझावा base रे तमर dt बुझावा तो tan theta is equal to dv upon dt हवा अब velocity upon time acceleration. So slope is tan theta and tan theta is equal to dv upon dt, which is nothing but acceleration. So in this case triangle ABC tan theta is equal to perpendicular BC upon AC. So instead of BC देखो initial point to final जाए तो हमारा velocity v, then initial point to A जाए तो हमारा velocity क्या है u. So इमेजिनरी velocity कितनी पावर v minus u because initial point to हमारा final जाए velocity v, initial to A जाए velocity u, तो इमेजिनरी velocity कितना है total v रू जब तक मैं A के काटी दबा तो इमेजिनरी का बचवा किने और इमेजिनरी velocity अकान bc है. So total v रू तो मैं a पे काटी दबो तो a जाए कितना होची u. So total v रू तो मैं u जाए काटो so बचबा v minus u. क्लियरली बुझलो तो bc जगह रे तो मैं लगबो v minus u and upon देखो लगा दैछे जे the time total t is the total time taken by the body to cover or reach final velocity v. तार माने ई इनिशियल पॉइंट रू then body का final velocity v जाउची तो ताके कितना टाइम लागुची t टाइम. So OD is represented as t, so in this case AC is represented as t. So instead of AC we can use t. So acceleration is equal to v minus u upon t. That means v minus u is equal to at. That means v is equal to u plus at. This is first equation. बहुत सहज है देखो डायग्राम भी बहुत सहज है किसी नहीं ना तुम डायरेक्ट बाहर करो जे देखो डायग्राम ही बहुत इंपोर्टेंट. So in 0 second the body has some velocity, initial velocity u, and with respect to passage of time the velocity of the body is uniformly increases. So in this case the total time is t and the body reach at final velocity v. किसी नहीं ना खाली ग्राफ के देखे छो अब किसी नहीं ना t टाइम रे फाइनल वेलोसिटी v हैला तो ग्राफ के नहीं साथी बारी बार ई पार्ट और ई पार्ट के जॉइन करले देन हमें स्लोप बाहर करबा के लाइन रे हिच छु बिकॉज़ स्लोप बाहर ले ही एक्सेलरेशन बाहर तो ई लाइन रे बने छ नले ग्राफ के ही बुझो छी देखो ग्राफ के ही रिप्रेजेंट करू देखो हल कर देखो बुझा जाउ छी. This is velocity graph and so in 0 second the body having some velocity u, and with respect to passage of time the velocity of body is equally increases, so slope will be straight line because uniformly increases. So suppose in t second तारमाने ई लाइन जोड़ेबा के पड़बा the body acquire final velocity v तारमाने ई लाइन भी जोड़ेबा के पड़बा. Then if we want to calculate the slope of VT graph, then compulsory we draw a tangent theta. That की join करवाल पड़ेगा. अब ये जब uniformly increase नीचे ग्राफ का जो straight line नीचे ताना ये भी दाम. Then this is C. So भाई किसी नहीं. So तुमको जब VT graph का slope बाहर करवाल से पहले क्या triangle use करवाओ? ये theta नीचे slope पाएगा जो tan theta. और tan theta is equal to perpendicular BC and base AC, BC upon AC, and their tan theta is equal to acceleration because perpendicular velocity के represent करूचे और base time के represent करूचे तो velocity upon time is kind acceleration. So tan theta is acceleration. So slope is tan theta and tan theta is acceleration. That means slope of the BT graph is acceleration. So in this case tan theta is equal to BC upon AC. So BC केते हवा ई O रो हमर ई फाइनल वेलोसिटी V और O रो A होचे इनिशियल वेलोसिटी U. So O रो V और O रो U जाय जदि हम काटी देबे बेले एते बचबा कि नै V minus U और that is equal to BC. तो BC जाके V minus U लेबे and धरो इरा जदि मुई D दी देबी बोले ई टोटल टाइम T टेकन करूचे बिकॉज़ ई T टाइम में फाइनल वेलोसिटी V होचे. So total time T होचे तो this is parallel to this is AC. So AC is T. So instead of AC we use T. So acceleration is equal to V minus U upon T. So V minus U is equal to AT. So like this is first equation. इन मिले चलो हला तो ठीक अछि थाउ नेक्स्ट हमें पढ़ो दो तीन टा इक्वेशन